All right, let's talk about something huge. What if one of the absolute cornerstones of modern physics, Einstein's special relativity, has a fundamental flaw right at its foundation? That's what we're digging into.
So here's the central question. What if the most famous thought experiment in all of physics, and you definitely know the one I'm talking about, what if it actually missed the bigger picture? What if its famous simplicity was also its biggest weakness?
Okay, so first, let's get back into Einstein's perfect little closed box. We're talking about his famous light clock thought experiment. You've got a train, a beam of light, and two mirrors. Let's see how it works from the inside.
Now, if you're an observer inside that moving train, everything seems super simple. The light just travels in a perfectly straight path, straight up and straight down, bouncing between the mirrors. It's a totally self-contained little world, a perfect closed box where all the rules make sense.
And this is what's known as internal consistency. And let me tell you, Einstein was an absolute master at this. Think of it like a perfect blueprint for an engine. On that paper, every single gear, every lever, it all fits together flawlessly. Mathematically, within its own defined world, it's perfect. But what happens when we stop looking at the blueprint and start looking at the real running engine out in the real world? What happens when we step outside that perfectly closed box and take a look?
And this, right here, this is the absolute heart of the critique. It's actually less about the math and more about a fundamental choice. Should a theory be valued because it's consistent with itself, that's the blueprint view, or should it be valued because it's consistent with physical reality, the camera's eye view of the whole shebang?
Because see, the argument is that reality is, well, it's nested. That train isn't its own little isolated universe. Nope, it's a box, inside another, and so on. The train is on the Earth, which is in the solar system, which is in the galaxy, and all of it is moving through this one big, overarching thing, the universal electromagnetic field. You know, the actual medium that light travels through?
And here's the real kicker. According to an AI analysis of this from the source material, this wasn't some simple mistake or an oversight. The claim is that Einstein deliberately cut the connection to all those outer layers. He did it on purpose to make his blueprint perfect, essentially ignoring the bigger picture.
So, with that new perspective in mind, let's go back and look at that famous light clock one more time. But this time, we're not inside the train, we're outside, on the platform, looking in.
And from out here, that light beam's journey looks completely different. I mean, of course it does, right? The train is moving forward, so the mirror on the ceiling moves forward while the light is in the air. The light has to travel in a diagonal line, a triangle, just to catch up to the moving target.
And this is where a little bit of high school geometry comes back to help us out. You remember the Pythagorean theorem, right? The path of the light is the hypotenuse of a right triangle. And what's the one rule we all remember from that class? The hypotenuse is always the longest side. So a longer path simply has to take more time. It's just geometry.
The source material has a great name for this, deviation shooting. And it's just common sense when you think about it. It's like a quarterback throwing a football. You don't throw it to where your receiver is, you throw it to where he's going to be. The light has to do the exact same thing. But Einstein's model, well, it kind of assumes the receiver is just standing still.
So, is this critique legit? I mean, this is a massive, massive challenge to a century of established physics. So to find out, the author of the source material did something really fascinating. They took this entire argument and laid it all out for a panel of modern experts, several different large language models.
And the verdict? Wow, it was fascinatingly split. You had Claude Sonnet come back and say, yep, the theory has decisive flaws and is wrong in an important way. Gemini Pro basically agreed, saying external consistency is a real problem. ChatGPT was kind of on the fence, calling it a valid design choice. But then you had Grok, which just dug in its heels and defended the old guard, basically saying, hey, GPS works, so the theory is right.
And the author of the source had a pretty sharp take on that split. They basically said Grok is, well, authoritarian. It just defaults to whatever the popular dominant opinion is. It seems less interested in the logic of the argument and more interested in just defending the status quo.
So where does all this leave us? It really feels like we're standing at a fork in the road, with two totally different maps for describing reality in front of us.
So let's just break it down. On one hand, you have Einstein's map. It's a collection of isolated relative little worlds, these boxes, where each one has its own perfectly consistent rules. In this world, internal logic is king.
On the other hand, you have the critiques map, one giant universal stage where all the boxes are nested inside each other. And in this view, matching the external, real world is the only thing that matters. Blueprint versus the camera's eye view. That's the choice. And that really is the ultimate question this whole thing leaves us with, isn't it? Which map actually describes the reality we live in? Is it a collection of separate relative worlds, or is it one single universal stage? And seriously thinking about that, well, that could change everything we think we know about space, time, and our place in the universe. Something to chew on. Thanks for diving in with me on this one.